Any property of a system that can be assigned a definite value for that system is called a state function. It's a property of the system that defines the system. So for instance, the temperature of a system is something that I can measure for a given system. The volume of the system is something I can measure. The number of moles in the system is something I can measure. The pressure of the system is something that I can measure. And so all of these things are state functions because I can assign a definite temperature, volume, number of moles, and pressure to any given system. In addition, the energy of the system is a state function. The entropy of the system is a state function, and the enthalpy of the system is a state function. Something that a variable that we'll meet later on called the Gibbs free energy is also a state function because any state of the system has a definite value of any one of these properties. If I have two states of the system, so I have some initial state of a system, and then I have some final state of a system, I can determine the difference between these two. So delta for any one of these properties, so X would stand in for any one of these properties, is the value of that property in the final state minus the value of that property in the initial state. And it doesn't matter how I get from this initial state to this final state. I can go through some intermediate state and then to the final state, or I can take 5 steps to get to the final state. It doesn't matter. All that matters is what the initial state is and what the final state is, and the change will always be equal to final minus initial, no matter how many intermediate states I go through. That is a property of state functions that's going to become very important as we move forward.